Okay, welcome back to another video. We are going to be looking at problem number 4C on the Chapter 6 review. We're going to be solving a system of equations using the inverse of a coefficient matrix. Okay, so to use an inverse matrix to solve a system of equations, essentially the idea is you're going to write it in the form of a matrix equation. So AX is equal to B. Okay? A is a matrix with the coefficients of the variables in it. So in this case it's 1, -2, 2, 2, -3, 1, 0, 1, -1. Okay? Because there weren't any x's here, that's why there's a 0 there. And then x is a single column that just has your variables in it. So x, y, and z. Okay? And that would be equal to the numbers that are over here, -1, -10, and 6. Okay? Because when you actually do this matrix multiplication over here, when you do, you'll end up doing this row times this column. So you'll do 1 times x, -2 times y, plus 2 times z. That's exactly what this equation is. It should be equal to -1. Okay? And so this is another way that you can write this this system of equations. And what's helpful about this way is that I'm trying to find what x is, right? I want to know what x is, what x, y, and z are, okay? What that matrix will equal. So what I can do is, if it's kind of like a linear equation here, if I had 2x is equal to 3, how do I solve for x? Well, I divide by 2 on both sides. The only issue with matrices is we can't divide by matrices, but we can multiply by something. Kind of like in this case, I could, instead of dividing by 2, I could also just multiply on both sides by 1/2. Then these cancel out and you get 1. And so you get x is equal to 3/2, right? The same thing is going to happen here, only for matrices, this idea of dividing is what's called the inverse matrix, okay? And it is kind of like doing a fraction of the matrix, but it is actually a matrix itself. So you're going to multiply both sides of this by the inverse matrix. And so when you do that, these two will cancel out, and you'll just get x is equal to A inverse times B. So all you will have to do is do the inverse of A times this matrix here, B. Okay? So in order to do that, we need to find the inverse matrix for A. Okay? And this was what this matrix is A, so we need to figure out what is A inverse. Okay? So how we do that, so we're going to find A inverse. Sometimes it will give you A inverse, and then you can literally just do A inverse times B. But I'm going to go through one where you actually have to find the inverse, because it'll be a good reminder of how we find inverses anyway. So you take your matrix A, 1, 2, 0, -2, -3, 1, and then 2, 1, -1, and you throw that in a matrix with the identity matrix on the other side. So the 3 by 3 identity matrix looks like that, right? 1's down the diagonal and 0's everywhere else. So now what we want to do is we want to get this to look like the identity matrix, the 3 by 3 identity matrix. So what I'm going to do is I first want to get this to be a 0, right? Because this is already a 1 up here in this corner. That's already good. You're going to do the same thing as you do for Gaussian elimination, just on this part of the matrix to get it to look like the identity matrix, but you will also do the same things to the rows that you do to this part of the matrix, okay? So, to get rid of this 2 here, you're going to do -2 times the first row, and we're going to add that down to the second row, okay? And notice that this is already 0, so I don't need to get rid of that 2, so we'll just do that one step. 1, -2, 2, 1, 0, 0, okay? So -2 times this row, so -2 times 1 is -2 plus 2 is 0, okay? This third row isn't changing either, so I'll just copy it down real fast. Okay, -2 times -2 is 4, plus -3 is 1. Okay, -2 times 2 is -4, plus 1 is -3. -2 times 1 is -2, plus 0 is -2. -2 times 0 is 0, plus 1 is 1. -2 times 0 is 0, plus 0 is 0. Okay, so there's our matrix. So we've now gotten at least this first column to look right. So now we want, kind of going along with Gaussian elimination, we would want a 1 here, right? And there is already a 1 there, so we're good. So then we want to use that 1 to get rid of this position right here, okay? So to make it 0. So I'm going to do negative row 2, and I'm going to add it down to row 3. Okay. And so when I do that, I get 1, 0, 0. The top row just stays the same. Okay. And the second row stays the same, but that third row is going to change, right? Negative row 2 plus row 3, those two cancel out, we get 0. -3 times a negative is +3, plus -1 is 2. -2 times a negative is 2, plus 0 is 2. And then -1 plus 0 is -1. And -0 plus 1 is 1. Okay, so there is our matrix, and we're really close. Okay, so now what I want to do is I want to get a 1 right here, 1 right there. So to get a 1 to be right there, I'm going to do 1/2 times that row, times row 3. And so we get 1, 0, 0, -2, 1, 0, 1, -3, 2. Oh, sorry. That all needs to get times by by 1/2, so we get 1, -1/2, and 1/2. Okay. To give me more space, I'm gonna pull out a new board here, because I know you guys are getting bored. So about time we got another board out. You guys are gonna miss my jokes, aren't you? Hopefully. Okay, so now what I need to do is get these two positions to have zeros in them. So I'm going to use this 1 to get rid of those two. Okay, so we're kind of doing Gauss-Jordan elimination here. We're going to do 3 times that third row, and we're going to add it up to the second row. Okay. And then we also want to get rid of that 2. We may as well do that at the same time. I'll do -2, row 3, and I'm going to add it up to row 1. Okay, so I'm going to do both of those in the same shebang. Don't do too many at a time, otherwise you won't keep track of it. But you can do it maybe at most 2 at a time. And you shouldn't do things where you're messing with, like, if you're going to use, like, notice in this one, I'm using row 3 in both of these to get rid of things in row 1 and row 2. These are different rows, right? So if you're doing something, you're adding it to the same row, that can get really confusing. So don't do multiples if you're doing them on the same row. Anyway, okay, so -2, row 3, we're adding that up. So that's going to give us a 0 there for the 3, and then a 0 here, right? This will still be -2, because these two positions are 0, right? So they're not going to switch anything. Okay? But now here's the fun part, right? Okay. Our last row isn't changing, but our middle two are. So I'm doing 3 row 3 plus row 2. So 3 times 1 is 3 plus -2 is 1. 3 times -1/2 is -1.5. Added to 1 is -0.5, so -1/2. 3 times 1/2 is 3/2 plus 0 is 3/2. Okay. And then -2 times row 3 plus row 1. So -2 times 1 is -2. Added up, give us a -1 there. -2 times -1/2 is 1. Added up is 1. And then 1/2 times -2 is -1, and added up. Okay. Okay, so we're almost there. The very last thing we need to do is get rid of that 2 there, right? So that it's the identity. So get rid of that -2, so we're going to do 2 times the second row. We're going to add it up to the first row. Okay. Whew, almost there. So 2 times 1 is 2, plus -2 is 0. So we've got the identity matrix there now for sure. Okay, but we were doing 2 times row 2, we're adding it up. So 2 times -1/2 is -1, plus 1 is 0. 2 times, that's the wrong place. 2 times 1 is 2, plus -1 is 1. And then 2 times the -1/2 is -1 plus 1 is 0. 2 times 3/2 is 3, and then plus -1 is 2. And then the rest just stays the same. Okay, so there's our matrix, our inverse matrix. So what you get over here, this part right here, this is your inverse matrix. So that's what A inverse is. Okay? And so, I now know A inverse, so I can solve my original equation. I'm going to get rid of all this because we're done with the row operation. So let's look back at what we were trying to do. We were trying to solve for x, y, and z in this equation. So I'm going to times on both sides of the original matrix equation by A inverse. And so I will essentially get that x, which is a vector including, so like a column matrix containing x, y, and z, this is equal to, we take our inverse matrix, 1, 1, 1, 0, negative 1 half, negative 1 half, 2, 3 halves, 1 half, and we're going to times it by negative 1, negative 10, and 6. Okay? Okay, so remember, how do you multiply matrices? Well, it's funny you should ask that because you probably know how to by now, I hope. You take rows of this and times it by the columns there. Okay, now notice there's only one column, so that makes our life a little bit easier. Okay, but then you're just taking this row here and then kind of flipping it and timesing it by these, okay, and then adding those results together. Okay, so what do we get here? Well, I do 1 times negative 1 is negative 1. 0 times 10, negative 10 is 0, so plus 0. 2 times 6 is 12. Okay. And then, what have we got on the second row? 1 times negative 1 is negative 1. Negative 1 half times negative 10 is positive 5. 3 halves times 6 is 9. Okay, and then lastly, 1 times negative 1 is negative 1. Negative 1 half times negative 10 is 5 again. 1 half times 6 is 3. So what's our answer here? It's 11, 4, so 13, and 7. Okay. So what does that mean? It means that x is 11, y is 13, and z is 7. So you'll notice this is a very efficient way of solving this system if you know the inverse, right? And if you don't, finding it is almost just as much work as solving it using Gaussian elimination. But if you do have the inverse matrix, this is a much more efficient way of going about it. So hopefully that kind of helps with that. After this, there's just one more video talking about Cramer's rule, and then you should be ready for the final. So you'll have to make sure you're just caught up on everything, and you should be good. We'll see you in the next one.